everyone, and welcome to today's webinar. I'm Melissa Romero, Forensic Science Consultant in C&EN Media Group. This webinar is Data-Driven R&D in Chemicals and Materials, Why an Open Platform is Essential. This event is sponsored by Dotmatics. C&EN works with sponsors to identify topics of interest and value to C&EN's audience and consistent with C&EN's mission to provide news and analysis of the chemistry enterprise in a timely, accurate, and balanced fashion. The presentation today is sponsored by Dotmatics. Dotmatics is a leader in R&D scientific software connecting science, data, and decision-making. Its enterprise R&D platform and scientists' favorite applications drive efficiency and accelerate innovation. More than 2 million scientists and 10,000 customers trust Dotmatics to help them create a healthier, cleaner, safer world. Dotmatics is a global team of more than 800 people dedicated to supporting its customers in over 180 countries. The company's principal office is in Boston, with 14 offices and R&D teams located around the world. During the presentation today, we will be hearing from Dr. Max Peterson. Dr. Peterson is the Associate VP of Chemicals and Materials Marketing at Dotmatics. In this role, Max is responsible for developing Dotmatics' strategy for the chemicals and materials industries. He has over 20 years of experience in informatics and simulation technologies in chemicals, materials, and life science applications. He also held business consulting in various technology leadership positions and also managed a lab automation company. Max holds a PhD in physics from Fritz Haber Institute of the Max Planck Society and a master's in physics from the Technische University in Berlin. So let's get started. I'm now going to turn it over to Max.
Oh, thank you, Melissa. Great introduction, and thanks everybody for joining us today. So as Melissa said, I work for Dotmatics. I'm responsible for the Chemicals and Materials initiative within Dotmatics. And in my role, I think what's really relevant to the audience here is that I talk to a lot of organizations about their R&D digitalization strategies. And I also work with our very talented R&D team to build the next generation of products. So what I wanted to share today is a little bit of our perspective of what's going on, and especially how these organizations are shifting towards a more data-driven way of doing R&D. So what I want to do is to talk very briefly about Dotmatics a little bit, just to set the scene of where we're coming from as a company and what we're aiming at. Then I'm going to talk a little bit about what data-driven R&D actually is. And then I'm going to talk a little bit about some of the product areas within Dotmatics that I'm responsible for some of the formulations capabilities. And I'll talk a little bit about the genealogy problem, something that I've recently discussed with a good friend of mine from BASF that I'm going to be talking about quite a bit here. But really to talk a little bit about what some of the challenges are when you're really trying to formulate products and the such. And then I want to talk a little bit about our approach to implementing these things. And then talk about some application examples, and then turn it back over to Melissa for a Q&A session. So what I like to do at the beginning of these type of presentations is to take a little bit about of temperature of where the audience actually is, and want to really talk about where you are on your digitalization journey, whether you are interested in digitalizing your R&D, but you have no plans yet, whether you're at the planning stages, whether you have isolated systems in place. So please take a moment and read through these questions, answer them, and rather to present you with the results of the poll right away, we're going to keep that for the end of the presentation, just so that we can use those later to basically introduce the Q&A and basically read you back what you guys thought. So another couple of seconds here for you to complete this poll. So thank you very much for participating. All right, yeah, thank you. So let's talk a little bit about where Dotmatics comes from. Really at the core of what we're doing is to trying to map the research workflows that every organization has onto a very core decision-making process, namely the decide, make, and test workflow. We're going to talk a little bit more about that at a later stage. But as an organization, we're actually pretty big. We have over 2 million scientists using our software. We have over 10,000 customers. And as you can see, there are some really heavy hitters in terms of chemicals and materials companies represented here. And I want to point out that as a company, we have two divisions. We have the platform division that I belong to, and then we have application divisions that basically provide functionalities on that platform. So that already speaks to the openness concept of our platform, that we're basically trying to incorporate applications so that they can be used seamlessly in a platform approach. So as a company, we were actually born out of the desire and the drive to basically unify data. Right? As we know, there's a lot of challenges around unifying data and making them accessible to decision-making processes, to data modeling efforts, or for repurposing IP, knowledge sharing. So it's a big challenge, and Dotmatics basically started out as a company, as a data federation framework that allowed organizations to basically unify their data silos. So over the time, this has morphed into a strategy where we're basically saying that we want to build a scientific platform that can connect best-of-breed applications to enable collaboration, automation, and analysis. And the idea is that if you combine the best-of-breed applications with a scientific data platform, you can really do scientific approaches that you couldn't have been doing before. So at a very high level, this works by basically taking this make, test, decide workflow and mapping them onto different scientific domain knowledges or the domain models like biology, chemistry, and formulations, or data management, and then allowing for a flexible combination of these domain capabilities and build out solutions that represent different scientific domains and applications. So more about that later in the presentation. But of course, on the capability side, basically you have on the decide side, things like predictive models, data visualizations, or data modeling efforts. On the make side, you have typical data tracking capabilities that are often mapped onto ELN or LIMS capabilities. And then on the testing side, you have data acquisition from instruments and, of course, analysis of these test methods. So here a quote from BASF that has been a long-standing customer of ours that basically states that they can really use Dotmatics to access different levels of information that they previously couldn't. And we've basically been a digitalization partner for a long time for them that basically allowed them to build a R&D infrastructure for them. So this leads us over to the question of what is data-driven R&D. Yeah, and at the very high level, again, this means it really maps on your digitalization objectives. Right, if you take a more historic approach, really digital R&D IT systems really started out with systems that would help individual productivity. And this actually take a slide that I took from a presentation where I was talking about the impact of the COVID crisis onto R&D digitalization. There was actually a very interesting perspective from a champion at DuPont that basically implemented our system throughout the COVID crisis, and really what pushed them over the edge was the need for their remote workforce to keep things going in the lab. Yeah, and it is with all the sustainability crisis that we have really looming over our heads. There's really a much bigger level of urgency to get more done, even if work is disrupted. So basically, at the individual productivity level, how can I get my work done if my work environment is disrupted? Or how can I operate a lab in a more remote fashion? Next, there is operational excellence. That typically falls into the category of virtual collaboration. How can I keep communicating with my colleagues? How can I automate workflows and basically implement best practices across different geos? And then on the top of it, we have the need to accelerate innovation. And this is really at the heart of what data-driven R&D is. How can I innovate faster using the data that I accumulated from all the basically foundational capabilities that I have put in place? So what does this mean for our customers? So we have a couple of quotes here. Again, BASF, scientists need the ability to do a variety of searches, looking over multiple experiments across many projects. Or here Arkema in a recent press release from last year. So it's really about implementing data-driven innovation, move towards data mining, and providing a foundation for artificial intelligence and machine learning. And that's really something that kind of crystallizes as a topic that organizations are starting to put more emphasis on the back-end infrastructure that are needed to do data-driven R&D. Speak machine learning can only be done if I have the right data in place. And the same thing is here echoed by Croda, who says digital continuity of the experimental data, faster innovation, and drive all of this by statistics, calculation and modeling, and artificial intelligence. So with that, I thought we do the second and last part of this presentation. What are your objectives? Are you trying to boost efficiency in the lab, optimizing data entry, streamlining data pre- and post-processing? Are you trying to improve data quality, such as, for example, implementing fair data principles? Are you trying to get more data standardization so that you can work more effectively with your colleagues that may be overseas? Are you trying to increase data transparency? Sharing data across geos, creating a knowledge management framework? Or are you trying to work towards, and I think there was something wrong in this poll, but the last question, please see that as, are you in the process of building out a machine learning or AI initiative? So if that applies to you, please use the last tick mark as such. And we'll recap that accordingly when we look at the results at the end of this presentation. All right, a couple of seconds here for you to complete this. Thank you for participating. All right, so let's get into the meat of this presentation here, the genealogy problem in formulations. And first of all, I should really state of what we mean by formulations. And it's really interesting to look at this in the context of what also differentiates chemicals and materials R&D from their counterparts in life sciences. So chemicals and materials is for me such an exciting area to work on, because the types of workflows are drastically different when going from application to application, but also from organization to organization. That means if we have a battery research group in one organization, they may structure their research very differently to the next one. And that's not only because they may be trying to do a cobalt substitution or trying to get the next best cathode defined, but really it's because it's part of their corporate IP and competitive differentiation. And that's very different from life sciences. If you go from one organization to the next, their, let's say, small molecule pipeline is highly standardized. So, of course, in a more downstream development context, that is really even dictated by regulatory bodies, but even upstream in discovery and research, the variability from one company to the other is very, very minimal. Excuse me. So the other thing is that, of course, the formulations problem, as I'm trying to show here, is kind of spanned by three main things. It's of course dictated by ingredient innovation, maybe trying to find the next best cross-linking agent for a composite application. But then it also is very focused on ingredient selection, which I noted here as basically the formula part of the process or the R&D workflow. And then process, where how do I actually combine the ingredients to make a product? And of course, there's a third dimension, which is the characterization part, to basically understand the performance of the new material. But for intents and purposes, you could think of different parts of these workflows existing somewhere in this triangle. So the life sciences R portion, the research or discovery part, is really very focused on purely chemistry, find the next compound and then synthesize it. But then all the other applications within chemicals and materials lie somewhere in the spectrum. And there's very, very few that are purely focused on one part of this triangle. So, for example, a beverage application may only live in the ingredient selection process, and all the work goes into understanding how do different locales provide maybe regulatory constraints or ingredient selection criteria due to local preferences. But all the other domains, they are kind of a combination of everything else, with maybe more emphasis on one part or the other. That if I'm looking at the composite workflow, maybe we are really thinking more about how do I process this material to get desired properties. So basically, the idea here is that formulation kind of encapsulates these workflows outside of the ingredient innovation part. And it's really what development in many of these organizations consists of. So how does this connect to data-driven R&D? Well, the challenge in the chemistry or physics or biology field is that they're of course very singular. If you're trying to model the activity of a certain drug molecule on a target, it's very singular, right? There's one molecule that will do the job pretty much, and all the others will fail. But in materials research, there is actually often a very smooth behavior that I can basically move the parameters of a product around and basically pretty continuously modify the ingredients' properties. And this, of course, leads to the domain of response surface modeling. And another big advantage is that small changes on this surface can make a very large impact. Right? Think about yield improvements for a catalyst or certain activity or performance of materials. So this kind of leads to this multi-objective optimization or Pareto front modeling that basically allows you to trade off performance parameters against each other. So this kind of makes the idea of modeling the behavior of these materials very attractive. The challenge is, of course, that we are typically not interested in interpolation, except maybe in a Pareto front exercise, but we're interested in extrapolation. We know the performance of the material in a certain region, but what we really want to know is, well, how does it behave outside of this region? And the extrapolation is by no means trivial, and that poses a big problem. And there's, of course, also what colleagues of mine have called the small data problem, that accessing this response surface is extremely expensive because you need to basically create experiments everywhere to measure the performance in the entire space. So again, that is more an extrapolation in terms of the performance in regions where we really don't want to invest experiments to map out the space. So that leads to issues and challenges around applying other models that may be more easy to basically extrapolate the performance in other areas, which is basically the inclusion of domain models. We really don't want to just go blindly at this and just have an AI model take over. But we actually know a lot about the domain science, right? Into fundamental chemical and physical interactions. And basically, how do we plug those into these models in a meaningful way? So what does this mean for a data platform? Right, so there's one first fundamental problem, which is to connect the materials definition to the actual experimental work that I'm carrying out. And that's by no means trivial because these products and these materials are generated generally in a multi-stage process. That basically means in order to carry out an experiment, there will be actually a sequence of events that leads to a final material that they can then test. And just to keep track of that is actually pretty challenging, because the experimental work often happens at the sample level, but the experiment happens at a higher level, where basically formulate or generate new combinations that then are tested in various ways. And then, of course, at the higher level, there's also this idea that if I'm having a rubber tire, and I want to understand where does it adhere to the road, there's a whole series of abstractions, right? I could go down all the way to a molecular level. I could provide granules as a feedstock. I could build dog bones to understand mechanical properties. And they all have to be connected to the relevant performance characteristics, which really spans your decision-making framework in the decide part of the cycle. So what's really more important to rather just map a performance space is really to understand how do I get there, right? And this is kind of akin to doing a mountaineering exercise, where basically I'm trying to climb the mountain from different routes, and these different routes will have different advantages. They may create more exposure to the elements, but may be easier to navigate, or they may be steeper and more challenging, or there may be more scenic routes. But in many events, really, it's about how do I climb this mountain? And if I'm doing a Pareto optimization, or if I'm looking at a reformulation exercise, I may want to jump between these different routes, right? And how this often generally happens in the lab is that different teams will explore these avenues, put their data to rest, and then I need to understand how on this very extended network do I go from one to the other. And of course, we now know, since we have climbed Mount Everest, that there's many of these traces or paths that will lead to the top, but they of course are all kind of different. Yeah, and I wanted to give a very short example of how to solve this problem with another area of our software, which is chemistry. And let's take a look at a piece of software that we built that allows you to crawl through a large number of chemical experiments and build out this tree. So I hope you can all see this, but here what we're seeing is a very standard piece of software which allows you to query substructures within an electronic lab notebook. So we see that there's a whole bunch of reactions in there, but what we're really interested is how are they all interconnected? Yeah, and by using a advanced query mechanism, we can now basically build out the entire tree of how basically a synthetic route has been tested out through a large number of experiments. So certainly a very exciting development, and building something like that out for formulations or process development, certainly very exciting. Which kind of leads me over to our platform approach. So within our platform, we basically have three main areas. We have what we call applications. And I mentioned that before, that there's a whole slew of applications that we can deploy on our platform. And then there is the core. And the core has in large strokes three areas. It's basically the electronic lab notebook capability, or the capability for the user to enter data into the system. And then there are capabilities that support these activities, like an inventory system, a registration system, or request management system. And of course, we have data management, which allows you to get the data back out, which can be done through data aggregation and search and data visualization. And then on top of these capabilities, we can now build solutions. And I'm basically responsible for the area that is at this point most relevant to chemicals and materials, which is the formulations innovation part and the process optimization part. Basically, they draw from these capabilities, but encapsulate them into a meaningful way that then allows you to do your research. So how does this work? Basically, we're using these capabilities to build out a whole bunch of workflows. So for product development, there is ingredient management. That means, and that's kind of really a core part of building out these systems, which is to understand your ingredients. What inputs are you going to use to define your product? And there's, of course, not only the ingredient names, but their attributes, and integration into inventory management systems that can then basically track where these sit throughout the life cycle of your experiments, and basically approval processes. And basically we're going to draw from different capabilities within the platform to basically implement them. Yeah, and then the same thing for formula, basically whether we're doing a de novo exploration, or we have a new design space, or expanding a problem. And also the results capture, which is basically keeping track of what was the specification of a product versus how did I actually dispense this in the lab. Then we have a process definition, which really draws on equipment definition, keeping track of their calibration statuses, and so on and so forth. And then on the testing side, we have test management, test assignments, results capture and results communication, and then ultimately, how would you analyze your results? So the other part of this is, of course, to define roles, right? And what these roles means is that different roles will have different access to data in a different way. So a researcher will basically have a very broad access to the data, but the lab technician who simply carries out the tests will simply see the data more in the spirit of a test request form. And then, of course, we have more managerial roles that can overview the project progress and so on and so forth. So let's take a look at a short video that basically shows all of this in action. And I'm not doing this so much to show you how our software looks like, but to highlight the integration of different systems that are needed to basically carry out the scientific workflows, and that they're drawing on different silos and basically needing to shift data between these silos back and forth. And while I'm going to be using Dotmatics capabilities to carry out this work, the openness of the platform means that in real life, we're integrating against existing data sources, whether that is a LIMS system or a registration system that was already in place, but we can build these workflows on top of them. So let's take a look at how this actually looks like. So here we're basically entering into the system, looking at all my experiments that are already in there. And now the user enters some metadata in there, whether this is a project, a customer-related piece of work. And then basically here we are in the formulations grid. And we already see some of these integrations happening. So basically now the user can draw from a list of ingredients that are relevant to the project he's working in. And then basically the ingredients have metadata associated with them that he can consume. Yeah, what kind of a role does this system or this ingredient play? And the batch ID. And the batch ID already ties back to other parts of the system. And once we have this data associated, we can now pull the information and show things like, well, what's the density of this? What kind of parameter is this? And this is actually a tableting example. This data has been straightly uploaded from the FDA. But then down here, you can see where this sits in your inventory. So there's barcodes that you can use to track your experiments. You can find them in an inventory location. You can find whether there is an expiration date that has happened. And we're actually now poking into the inventory system into a specific shelf to see where these ingredients are. And there are basically now ingredient levels, barcodes, and so on and so forth. So very rich context that comes from different data sources. Yeah, so now basically having all this information, let's take a look at where does this information come from. Yeah, obviously you could create a database and integrate this, but what we're using here is actually our bioregister system that basically really acts here as a generalized entity registration framework. And this is now the excipient database from the FDA straightly uploaded into our system. So there's really no programming required. You define this entity, and it's also a very convenient way of partitioning out ingredients into different projects and doing different things. Now, a very important part is sample information, right? So now we are saying, well, it's all great to define the formulations, but what I want to really do is to attach those to samples. This could be a launch-off point to push this into an LIMS system. Of course, here we're using our internal capabilities. And you can see that there now are a list of samples that I can now request tests on. Yeah. So I can basically select the sample here, do a request, and now we're in the Dotmatics request management system. I choose an whatever HPLC or a stress strain analysis, and I can kick this off to a lab to do this request, right? And now the tester can go in, find this request, do the work, and then at the end of this process, I can of course see the results in here. So that's basically how this works. Let's talk about a couple of application examples here. So basically for each of these examples, this make, test, decide cycle will look differently. Yeah, this is actually an example for tire research, where you can basically see some DSC curves that have been done on the different samples, and then different kinds of performance evaluation that are relevant for this type of research. Basically, we're decorating the cycle with the different relevant applications and tests that are relevant. So the most basic level, we can create what we call LIMS type workflows. And this really only applies to chemicals and materials at this point because we're still working through our validation processes. But what we do really well is to map these complex multi-stage sample processes onto workflows and basically providing a way of interconnecting IT systems that can basically now be harmonized. We can support all kinds of science on top of that. We can really provide a very effective way of configuring the workflows around them. And then there's, of course, going to get increased data quality, better collaboration, and better insights. So this kind of works along the ways of some of the stuff that we've already seen, basically creating a formulation, creating a bunch of samples, tracking them throughout their request management, and then basically returning the results to the scientist. Next, we can combine this with other applications. So basically, we can jump over and add a chemistry model into the mix, and then have a way of dealing with polymeric systems where basically the technical complexity comes into connecting these very complex entities into this multi-stage process. Yeah. And this basically now creates a single source of truth, that chemists who may be optimizing end groups or specific functionalization of the polymers to the teams who actually develop the products and connect everything together. Don't want to show any more slides on that because it's pretty self-explanatory. But one thing that's really exciting is when it comes to alternative feedstocks, which is an area that's really growing very rapidly, you can now connect your genotype to phenotype workflows that happen in the biology labs. We're going to genetic engineering, strain improvement, purification, and then testing, and interconnecting those to your material to product workflows, where you're basically doing formula development, sample synthesis, decide workflows to connect these workflows together and build a bridge. Yeah, and this is kind of something that we are working on in the proof of concept work. So basically, here we're connecting to some of these other applications that I mentioned earlier, namely Genius Prime, which is a tool to basically define biological entities and then connecting them to our registration system, then doing assay studies, and then connecting this back to the decision-making problems. So basically turning all of this around and then connecting it to the formulations workflows. So with that, I'm getting to the end of my presentation here. I hope I've been able to tell you a little bit about what happens in the area of data-driven R&D and how organizations using them to aim really at accelerating innovation. Our platform really helps solving some of the data interoperability challenges and how an open platform is really the only way to really solve this, and some of the exciting applications that our customers are doing. So with that, before I turn it over to Melissa, let's take a quick look here at how we did in terms of where you are in the digitalization journey. So interesting split here. Yeah, there's actually quite a number of people who are interested but have no plans yet. And then the second biggest group is this group who has these isolated systems in place. So really interesting here. Thank you for participating. And let's take a look at the second part. What's your data objectives? So the strongest representation is actually the ones who are trying to boost efficiency, simplifying data entry, doing data pre- and post-processing. And then the second biggest group, and this is kind of where we kind of have a little hiccup here, are actually the ones who are trying to implement AI and machine learning. So really interesting feedback. Again, thank you for participating. And now I'm going to turn it over to Melissa, and let's see what kind of questions we have coming back from the audience.
Right.
But so far, thank you for joining me.
Excellent presentation, Max. Yep. How you doing? You did fantastic. It was great. We got a lot of audience feedback that they thoroughly enjoyed it. And I just want to remind the audience, too, that you can ask questions through the Q&A box on your screen. And with that being said, I have your first question for you. An individual is asking, does Dotmatics have within it information about ingredients, such as chemical composition and structures? And if so, what are the data sources?
Yeah, well, this is the exciting thing, that you can really structure this completely flexibly. We have customers who reach back all the way to the chemical entity. That is the main functional part of the ingredient. You can define ingredients as mixtures of other ingredients and deconvolute that. And you can also connect other aspects of the ingredient to it, like, for example, a safety data sheet or a risk assessment relevant information, and have those, for example, sitting in a completely separate system. Yeah. So we have customers who actually use their SAP system to manage the safety information. They have a third-party chemical registration system to manage the chemical information or the chemistry information. And they may even have their own ingredient tracking system that they can point at. So there is actually a big degree of flexibility. Yeah, and if you were to use Dotmatics out of the box, we can also replicate a lot of these data sources or migrate existing data sources. There's actually a lot of work that goes into that. And as the question shows, this is actually a very important part of the entire process.
Okay.
I hope that answers the question.
We have another question from another audience member. They are wondering, how does supply chain availability of ingredient management, cost contracts, and overall profitability to the company apply?
Yeah, so basically, supply chain disruptions typically on the R&D side lead to reformulation exercises, right? That you need to substitute one ingredient with the other, and basically trying to then model a performance that at least gets close to the original performance with the ingredient that is to be substituted. And basically, in order to model this, you either would want to include costing data, that can of course also then be regionalized, and then plug that into your models, right? Basically, these are typically thought of as kind of marketing requests that basically kick off your development workflows, and then basically in the decide phase, you would see if you have a reasonable performance that matches these requirements.
Okay.
So.
Okay, good. I'm sorry. I was just going to let you know that the audience member also added another part to that question. So maybe
yes.
this might also, you want to hear this one. It's adding to the supply chain question. They wanted to know how the regulatory landscape, how does the regulatory landscape and how is it updated as that landscape changes?
Yeah, so basically the supply chain modeling and regulatory compliance, these are of course systems that would live outside of Dotmatics, right? We're not a supply chain planning company, but they would become inputs into a research project or a research request that would enter into this decide, make, test cycle. So the regulatory questions often are, again, then falling back to a reformulation problem, because let's say I have to replace BPA and all of my formulations, that basically now becomes what's the best next plasticizer that I can use that has a regulatory seal of approval in the region that I'm trying to develop for. Yeah, and the limits of what is allowable now becomes a constraint onto your formulation allowed ingredient range. Yeah, that you basically could think of this again as a Pareto optimization, where you basically only allow that level of ingredient to be present in your formulation, and then you can basically select the best performing candidates from that, right? So I hope that answers the question.
If the audience member wants to follow up, I'm sure that they can.
Happy to continue this. Please. Mm-hmm.
Yeah, I know lots of companies are definitely having supply chain issues these days.
Absolutely,
Right. This audience member was wondering is your platform open, and how would you go about integrating other systems or applications into it?
Yeah, so that's kind of what we specialize on in open platform technology at the most basic level. We basically have a data access layer that basically actually under the hood attaches the Dotmatics data sources in exactly the same fashion to our data platform than a third-party data source. Yeah, basically, the API allows the interconnectivity, and then there are data standardization and ETL capabilities in the platform that can basically normalize the data and provide them as a valid data input source. Same on the application level. So basically, the simplest is, for example, a sketching tool where we basically pass back and forth the actual specification that, for example, defines a chemical entity. Yeah, and then basically all these applications that I mentioned that we're integrating into the platform operate in a very similar way, that we basically use whatever interfaces are available, RESTful APIs, ODBC connections, or whatever is available to basically allow for the data transfer between the platform and the applications or data sources.
Okay, great. This individual is wondering, can you add machine learning models to your system, and how would that work?
Yeah, you can, and we have. Yeah, so we really understand our efforts in the machine learning area more as a democratization effort. Yeah, that you basically say, well, it's great to have a statistician develop a new model, but what happens if I want to apply them to a larger audience, right? And there's different ways. So the one way we've explored actually quite extensively is to deploying them within our data visualization framework. I don't know if I can move back here to my little box chart. Basically, yeah, this is kind of the at a very high level, the architecture of this. This is actually our data visualization tool here, Vortex, and basically, this is a data visualization form that has a direct connection to the data sources. And basically, there's a whole presentation that I could share with you, how we can basically embed machine learning models in them so that we can either take select training sets from existing data, then doing validations, and so on and so forth. So this is one way. Then the other way that we're exploring is to basically supplement directly machine learning results as basically virtualized test results within the ELN. So again, happy to follow up on that in more detail. So thanks for the question.
Okay. This individual was wondering, does your system also work if we are already using an ELN from a different vendor?
Yeah, it does. So, for example, this very short video that I showed first, basically which did the mapping of the synthetic routes, actually pulled data out of a third-party ELN to provide that information. Yeah, so basically you can operate the platform on top of an ELN, but then of course it becomes more of a data analytics and data harmonization tool to really pull information together and make useful decisions from that and do data analytics work. So we have various examples of customers using our platform in that fashion.
Okay. And this is about the last question that we have time for today. How about instrument data? Can you read them directly from the instruments, and can you process them? Yeah, so basically one of these tools here that is not lit up, Prism, is actually a high throughput data analytics tool that can, for example, pull in stress strain curves and basically do automated curve fitting on demand. So this is really a big time saver, and of course, and also a great way of standardizing your data analyses. And then you see here this box instrument integration on our architecture here. And there's various ways of going about this. Yeah. So for example, if your system
pushes out data in a machine-readable format, which is non-proprietary. You can actually do a direct upload into the database and then do the processing from that. For example, our assay tools in cheminformatics work very much along these fashions. We're also working on a more sophisticated frameworks that can basically parse instrument proprietary data, but that is kind of still a little bit work in progress.
Okay. One more question just came in, and I think we can sneak it in if there's hopefully it's a quick answer. So, does your system also work with systems from production data? If, for example, if process data is available in SAP, can data analysis and analytics be done on that?
Yeah, so a really great question. That's something that we're starting to explore more and more. And to go to the downstream process development, so we have several projects going on there, and delighted to follow up more in detail on how that would actually look like. But we have done successful integrations into SAP, and it's all in the realm of possibilities. Yeah.
Okay, excellent. And that's about all the time that we have today. For any of the questions that we didn't get to during the session, Max can also answer by email. Again, a huge thank you to Dr. Max Peterson for this excellent presentation today. Thank you to the participants today for being a great audience. Be sure and check CNN or CNN Online for information on the next edition of CNN webinars. Thank you to On24 for the technology and production services, and a big thank you to Dotmatics for the sponsorship that made this interactive webcast possible. For CNN webinars, I'm Melissa O'Mara. Goodbye.